All right, today we are going to continue on with what we began last Thursday, talking about the distributive property. Okay, we looked at the very basics of the distributive property. I think everybody was pretty good with distributive property. It wasn't anything new for anybody. But the distributive property can apply into some tougher types of situations, some tougher problems than the ones that we looked at on Thursday. So let's see how the distributive property applies to what we call rational expressions. Now, does anybody know this term, familiar with this term, rational expressions? If I say rational expression, do you know what that means? Nobody? Exactly. Okay, rational, that's very good. Good breakdown of the word. Okay, there you go. Okay, the root of rational is ratio. Okay, so ratio is a fraction. Okay, so when we talk about distributive property of rational expressions, then obviously we're talking about having some fractions in our problem, just like Louis said. Okay, and that's exactly what it's going to be. We're going to have to deal with some fractions, and the distributive property applies a certain way when we're dealing with fractions. Okay, but first let's break it back down to something we talked about in the fall semester. How do you multiply two fractions? Okay, what do you do? Cross multiply, add stuff up, find common denominators. What do you got to do to multiply two fractions? Find common denominators? What do you think? Y'all think he's right? Nobody disagrees with that? Okay, we should be disagreeing with it because it's not exactly right. The common denominator thing is if you have to add or subtract fractions, and we'll actually be looking at a little more of that tomorrow. When you're multiplying two fractions, actually multiplying two fractions is one of the easiest things that we get to do with fractions because it's not a big deal. We just go straight across, okay? And multiplying two fractions is the only place you ever get to do that. With adding and subtracting, we have to do find common denominators. With dividing, we have to do leave, change, flip. Okay, multiplying is pretty simple. We just multiply straight across the numerator, multiply straight across the denominator. Okay, so if you were presented with a problem, something like 2/3 times 4/5. Well, how do you do this? 2/3 times 4/5. What do you think? Straight across, straight across. So you're going to go 2 times 4. You're going to go 3 times 5. So what's the product end up being? Yeah, numerator's going to be 8. Denominator's going to be 15. Okay, and we'll watch out to see if anything reduces or not. And it's possible it will, and it's possible it may not. Okay, 8/15 isn't going anywhere. They don't have any terms in common. Okay, but so that should be old news to you. Now we're dealing with all kinds of variables and exponents and things like that here recently. So if you happen to have variables present in these fractions and you're doing this multiplication, well, we'll follow the rules for combining terms. We'll multiply things, combine stuff, follow the laws of exponents, and so on. Okay, so a little bit of review there. Okay. Also should be a little bit of review. It's still just two fractions multiplying together, right? Just like the last one. What's so different about it? Yeah, it's got variables in it, but there's nothing different, right? It's just different values that are in it. Okay, but two fractions that are being multiplied together. How do you multiply two fractions? Straight across the numerators, straight across the denominators. So we're going to go straight across, straight across. So have a look at it. Tell me, what's going to be in the numerator? Say again? No, in the numerator. Yeah, there's going to be an m to the first, there's going to be an a to the first, and there's going to be x squared. Exactly right. Okay, now what's in the denominator? 8y squared, right? Y times y. Add the 1 and the 1 up for the exponents, 8y squared. There you go, amx squared over 8y squared. And of course, these problems can get as ugly as the person who puts them together dares to make them. Okay, but the rules are the same. Now, using the distributive property where fractions will be involved is going to be really no different than just multiplying these two fractions together. Okay, so let's take a look at what distributive property is going to look like if we happen to have rational expressions. Now, while you're scribbling that down, okay, let's review what we said on Thursday. We have a value that is trying to multiply by a set of parentheses. Okay, it's an ugly value, x squared over y squared, but it's still just a value, right? Okay, still just a fraction, some number sitting out in front of the parentheses. So it's trying to multiply its way into the parentheses. Okay, well, so we're going to have to let the distributive property apply. The fact that it's rational really doesn't change much except for the way that we distribute, because the numerator of our coefficient out here, this x squared, when it multiplies in, it's going to go hit other numerators. The denominator, since we're rational here, we've got denominators, y squared, when it multiplies its way in, it's going to go find other denominators. Okay, so just like we were working on just a moment ago, the distributive property is going to operate exactly the same way. There's just more of it. Okay, so let's have a look here. When x squared starts distributing, it's going to go get other numerators. What's going to happen with this very first numerator? What's this value going to be? What, say again? 1, x squared times x squared? X to the fourth, right? Law 1 for the laws of exponents said if you're multiplying x times x, same bases, what do you do with the exponents? Add them up. So we got 2x squared, and we got x squared, that's a 2 and a 2, and we add them up, x to the fourth. So right there, that's x to the fourth. When x squared comes out back here and gets this 3y cubed, what's that going to be? Okay. Well, the 3 will still be there, right? These x squares, do they have anybody to add up with or combine with? No. What about these y cubes? No. So they're just all going to be there, right? The 3 will be there, the x squared will be there, the y cubed will be there. It's just going to be part of the deal. All right. Now, so that's how the numerator distributes. The numerator has to go get every other numerator. Now, y squared in the denominator, it has to go get every other denominator. So here we go. Y squared times y. What's this? Y cubed, exactly. Law 1 of the laws of exponents. Add them up. How about this guy? Multiplying back times that m. Yeah. The m's going to be there. The y squared is going to be there. Okay. So there we are. You said there would be x to the fourth, said it would be 3x squared y cubed, and in the denominator said it'd be y cubed and my squared. Okay. Now look at these two ratios that we have here being subtracted. Is there anything that can be simplified? Okay. Let's look at this ratio. Anything can be simplified on this lead term here, x to the fourth divided by y cubed? Can we combine x's and y's together? No, they're not going anywhere. So that lead term, that fraction is exactly the way it's going to be. How about the trail term back here? Okay, anything that can be combined or simplified? What do you see, Patrick? Yeah, you got y's in the numerator, y's in the denominator. That's this ratio is not done yet. Okay, now how's that work? We got y cubed in the numerator, y squared in the denominator. What do the laws of exponents say when you have y divided by y like that? Uh-oh. Exactly. There y'all got it. Okay, if you have the same base being divided by itself, y divided by y, the rule says to subtract, and it says numerator minus denominator. So we're going to get 3 minus 2, which will be 1. Okay, since it's a positive value, that y is going to be in the numerator. If it had been negative exponent, the negative would have sent it to the denominator, then it would have been positive. Okay, so we're going to, instead of having y cubed in the numerator, y squared in the denominator, it is just y to the first in the numerator. Okay, see anything else in there? Numerator's got a 3 and an x and a y. Denominator's only got an m. They don't have anything else that can be combined. There you go. This is your answer. Now, There is another step we could do to this. Okay, we have a fraction minus another fraction. What do we say we have to do when we want to add or subtract fractions? Find common denominators. Okay, we're going to talk about that, pardon me, talk about that a little bit more tomorrow. Okay, but for right now, for today, this is okay. I'm going to let you leave this as your answer today. Tomorrow we'll look at finding the common denominators and actually getting this down to one term. Okay, so for today, I'm going to want you to distribute. I'm going to want you to simplify. But once it's simplified out, you don't have to worry about combining the terms or anything like that. Okay, let's look at another one. Now, what is it going to change that this time we're not multiplying by a binomial, two terms, like we did on the last one. This time is a trinomial, one, two, three terms we're multiplying into. What does it change? Nothing. Okay, you just have more terms that when we do the distribution, okay, that AB over X squared, or AB over C squared, pardon me, it's just going to have to hit more and more terms. Okay, they could put 100 terms out there in that polynomial if they want to. That's fine. That just means we're going to have to hit 100 terms when we do that distribution. Okay, it's rational. We've got fractions. Okay, so all we have to do is just remember that when it comes down to having rational expressions, numerators are going to go get other numerators, denominators are going to go get other denominators. Okay, so let's have a look here. I believe I've got the graphic that goes along with that here in a second. What are we going to do with this guy, this middle term sitting right there? Yeah, everything's a fraction, right? Everything is a fraction, whether it's written as a fraction or not. So when this c squared wants to come out to here to hit this 2bx, it's going to look for another denominator to hit. Okay, what's in this denominator? They did not write a denominator down, so what is in the denominator? A 1. Okay, automatically. Remember, anything in math that's missing, it's a 1. Okay. So there's a 1 in that denominator, so you might want to even draw your problem that way if it helps you remember that there is a denominator to actually hit. Let's see what we got. What's this going to be? AB times ABX. Not exactly. What's A times A going to be? A squared. What's B times B going to be? B squared. And what about that X? It's just going to be there. Okay. What's this guy? AB times 2BX. 2A B squared, right? And X. Cool. What's this guy going to be? 4A B. Yeah. Okay. All right. So the numerator's not so bad. Let's check out the denominators here. What's this first denominator going to be? C cubed, exactly. Next denominator? 1C squared. Okay. And the final denominator? C to the fourth, right? 2 and 2 will make 4. Okay. All right. Have a peek at those three ratios. Do you see anything in there that might want to simplify down? I don't see anything. I mean, it's pretty easy to spot. All the denominators have is a whole bunch of C's. Do any of the numerators have any C's that they could be combined with? No, there's nothing there. Okay, so again, for today, this is going to be our answer. Tomorrow, we'll worry a little bit more about how can we combine those fractions. Okay, we'll look at some common denominator stuff. Okay, anybody have any questions over how that worked? Okay. All right, we're just going to look at one more. I want you to scribble it down on your paper. I'll give you a couple of minutes head start, and then I'll start working through it as well. And we'll see if we come up with the same answer. After you do your distribution, you ought to end up with something very similar to that. The only difference in what you might have on your paper might be the alphabet. Okay, that you might have it. You might not have it in alphabetical order. And again, it's not incorrect if you don't have it in alphabetical order. It's just not the way you're probably going to see it on a test. Okay, so from here on out, the next step would be to look at the ratios and see if any of the terms might be able to be simplified in there. Okay, so if you got to this step, take another moment, have a look at these two ratios and see if anything will simplify some. Looks to me like we have some opportunities to simplify there, 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 and there. Okay, from that, what I see on the lead term, I see a divided by a. That's a to the first divided by a to the first. Law 2 says to subtract the exponents. So 1 minus 1 is 0. We have a to the 0. What happens when you have something to the 0 power? The value is just 1. So a divided by a is nothing more than a 1. Okay, so we're done with the a's on the lead term. Same thing, m divided by m, that's m to the first, m to the first. 1 minus 1 is 0. We have m to the 0. That is nothing more than a 1. Okay, how about this guy? P divided by p squared. Okay, well, that's a little bit more complicated. We got a numerator of 1, a denominator of 2. 1 minus 2 is negative 1. Okay, so we have a p to the negative 1 in the numerator. But what does a negative exponent do? It tells us that that value, that variable, does not belong wherever it is. So if we got p to the negative 1 in the numerator, then that is telling us it doesn't want to be in the numerator, it needs to be in the denominator. So what we will end up with is a p to the first in the denominator. Okay. Everything else didn't seem to have anybody to cancel with, which would leave us the x is still sitting in the numerator, and the k in the denominator didn't have anybody to combine with, so there it is. Okay. Let's see what's going on in the trail term here. We've got a 2 in the numerator, doesn't have anybody to combine with. We have an m to the 5th in the numerator and an a in the denominator. Now what about the p's? We got p to the 4th in the numerator, p squared in the denominator. Law 2 says take the numerator's power, which is 4, and the denominator's power, which is 2, and subtract them. 4 minus 2, positive 2 in the numerator. P to the positive 2 in the numerator. That's all well and good. We don't have to move that. Okay. Always a good idea to look over the problem one more time, make sure you didn't miss anything, make sure you don't have any negative exponents, any zero denominator or zero exponents or anything like that. I don't see anything else that looks like it wants to simplify. So again, we're going to leave the term just like this, the expression just like this. Tomorrow we'll worry about the common denominators, go take it one step further there. Okay? But there you go. This is your answer. All right, that's pretty much all we've got from here on out. Let's see if we can't get a little practice on it. So let's get the worksheet.